Hello chemists, it's lab time, and today we're going to do a lab on titration. Titration in this case is where we're going to use an acid or an acid of unknown concentration. We're going to use a base of known concentration. We're going to do a reaction till we get it neutralized. Excuse me. And then we're going to be able to calculate what the concentration of the acid is. Neutralization is when you take an acid and a base and you produce water and a salt. In this case, we're going to use hydrochloric acid and sodium hydroxide to make water and sodium chloride. Acids start with an H, bases end with OH. Acids have a very low pH, close to 0 or 1. Hydroxide, sodium hydroxide is a pretty strong base. It's got a high pH, close to 14. But their mixture of the two, water and salt, is what we get out of this at the end, is we get a neutral pH of 7. All right, now, why does this thing work? I want you to notice in this balanced equation that we have here that all the coefficients are 1. And so that means there's one acid for every one sodium. All right, now let's go over here and let's look at the formula that we're going to use. All right, the formula is acid concentration times the acid volume is equal to the base concentration times the base volume. Another way to say that is the molarity of the acid, which is our unknown in this case, times the volume of the acid equals the molarity of the base times the volume of the base. Now, why does this formula work? If we look at molarity, molarity is moles of HCl's per liters of HCl. And if we're going to multiply that times the volume in liters of HCl, we can cancel out or cross off or divide out the liters of HCl, and it leaves us moles of HCl. We do the same thing on this side. Moles of NaOH over liters of NaOH times liters of NaOH means we can cross off the liters of NaOH again, and we're left with moles of NaOH. So this means that for every 1 mole of HCl, we're going to get 1 mole of sodium hydroxide. All right, so now we kind of have the basis of why this works. Let's go do the lab. All right, so here are the materials that we're going to need for this lab. Obviously, we're going to need some acid, and so here is a bottle of acid. We don't know its concentration. I'm going to use this beaker for the acid. Here's our known solution, or concentration of sodium hydroxide. It's 0.20 molar. Good thing to remember, 0.20 molar for the base. You're going to need that for the concentration. And I'm going to use this beaker, separate beaker, different beaker, so I don't contaminate it, to fill up the burettes. Burettes are these very expensive pieces of glassware. It's a glass tube. And if you look closely at it, I hope you can see this, okay? But it's calibrated, and so it's in milliliters, and it's in tenths of a milliliter, so we should be able to measure to the hundredths of a milliliter if we do it properly. So we're going to need one of these burettes for the acid, one for the base. So I have 2 of these glass tubes that are calibrated, and they're pretty expensive. All right, I need something to hold them in. This is called a burette clamp. So I'm going to clamp this to my ring stand, and I'm going to put the acid on the left hand side and the base on the right hand side, A, B. So it's kind of in alphabetical order, reading left to right. And then I have these 2 little valves here. These are called stopcocks, and they insert into the burette like that. And if the stopcock is in line with the burette, it's completely open. What acid or base is going to go right through here. If I have it perpendicular, that shuts it off, just like the gas in your house, those kind of valves, shuts it off. And by varying the amount, turning it like this way, you can get it to drip real slow, or you can get it to pour out real fast. All right, so I'm going to assemble these things now. Oh, and we need an Erlenmeyer flask to do our neutralization in. All right, so what I did is I set everything up here. You can see the burette clamp here in the middle. I have my acid on the left-hand side. I've already filled it up, and I've made it so it's right at 0 right now. So the acid, you could write down for the trial 1, the starting volume of acid is 0.00. Same thing for the base. I filled this side up with the sodium hydroxide of 0.20 molar, and its starting volume is 0.20. All right. So what I want to do is I want to put 10 milliliters of acid into the Erlenmeyer flask. All right, so all my focus is going to be on watching this and making sure that this goes down to 10 milliliters. All right, so I'm going to have to adjust my burette a little bit here so I can see it a little better. And notice I put the stopcocks set up so that they're on the right hand side because I'm right-handed when I do this. All right, so what I want to do is I have my burette and I'm going to put that over the top there and I'm going to try to catch this. All right, so what I'm going to do here is I want to get 10 milliliters. So I'm going to focus on this and I want to get it down to the 10 milliliter line. So I'm trying to do a lot of things here at one time while I'm doing this. All right, so what I'm going to do here is I want to get 10 milliliters. So I'm going to focus on this and I want to get it down to the 10 milliliter line. So I'm trying to do a lot of things here at one time while I'm doing this. So I'm going to add till I get to 10 milliliters. All right, so I'm going a little bit at a time. I don't know if you can see that very well, but it's just barely dripping out here. And so now I'm down to 2, 2.5, 3, 4, 5, 6, 7 milliliters, 8 milliliters, 9 milliliters. I'm going to try to get this exactly on 10. If it's not exact, it's okay. Our calculation will take care of that. And there, I got it. If I look at that carefully, that should be right on 10 milliliters, the bottom meniscus of 10 milliliters. All right, now that I've got the acid in there, I also need to add 1 or 2 drops, 3 drops of phenolphthalein. So I put 3 drops in there, and it shouldn't be surprising that it didn't change colors because phenolphthalein, and it's an acid, stays clear, and when it hits neutral and goes to a base, it's going to be just slightly pink. Okay, so that's what we're trying to do, is get to just slightly pink. So what I'm going to do is right now, if I look up here, my acid is right at, or excuse me, my base is right at 0.00. So I'm not going to focus on this. What I'm going to do is I'm going to focus on what I got going on right here. And I want to make sure I get that just pink. So what I'm going to do is I'm going to swirl with one hand. I'm going to move this down just a little bit like this so it makes getting the base in there easier. I'm going to swirl with one hand, and I got this white background paper up here so that we can kind of see when it turns pink easier. All right, so here we go, and my focus is going to be all on the flask here because that's the one that's going to change color. All right, so it might be easier for everybody if I do it like this so we can kind of see. You guys can kind of see over there in the front. So anywhere, when I do this for the first time, I do go really slow, drip by drip by drip. And I don't know if you guys can see that well, but it just turns barely pink every time there's a drop added to it. So a drop hits and you swirl it and it disappears. So we're going to go nice and slow here, drop by drop. So there's a drop every couple seconds here, and I'm going to constantly swirl. And this may take a while because I don't have any idea how many drops it's going to take. The person who gets to do trial 2 will have a better idea. But I hope you guys can see that. You get just a pink drop and then it disappears when I swirl it. Because right around that pink drop is where all the base is at. But it gets neutralized. The acid and the base neutralize each other, goes neutral, and so then it goes back to clear. All right, so you guys can kind of see in this other camera here, hopefully, that it is turning pink with every drop, and it stays a little bit longer each time. So it's just a drop every couple seconds that's showing up. All right, and I'm going to kind of slow this down a little bit because I think I'm getting close. Okay, so now I'm going to try to add one drop at a time because it seems like my pink color is staying around a little bit longer each time. So I'm going to add one drop, and I'm going to swirl. Oh, and look, there it is. That one drop made it just turn pink. I'm going to swirl a little bit more. It may go clear. No, but that's it. So now it's just barely pink, and that's exactly what I'm looking for. So I'm going to go up here. I'm going to read what it says, and it says for the volume 4.80 milliliters. Okay, here we go.
All right, so I got some phenolphthalein, or no, this is just water?
That's just water. I rinsed it out. You can pour that out if you want to.
Okay.
All right. By the way, you guys, this is Mr. Januszewski, chemistry teacher. He is going to he's the second team member here.
All right, so right now I'm at 10 milliliters, and I need to add another 10 milliliters of our acid. So I'm going to open up and drop down 10. I got 12, 13, 14, 15, 16, 17, 18, 19. Now I'm getting close. 20 milliliters will get me to the 10 milliliter mark. So I'm going to slowly open that up. Get it eye level. And all right. So now I've got my 10 milliliters of acid, and I'm going to add my indicator called phenolphthalein. How many drops you want on there, Mr. Bro?
Oh, 1, 2, 3, whatever you feel like comfortable doing.
3 is my lucky number. I was
nice.
born on 3/23/83.
Wow, that is lucky.
Mm-hmm. Lucky for my parents, too, that I was a gift to them.
That's the rumor.
All right, so now that I have my acid and my phenolphthalein, every time it touches base, we should get a nice little pink color. So the question is, how much base is it going to take? So right now, I'm looking at starting at 4.8 milliliters. So I'm going to start adding it drop by drop. And to begin with, I'm going to do a quick twist. And if you can see, every time the base is added, you get a little pink color, and then it goes away. And what's happening is, every time that base touches that acid, the indicator picks it up really quick, and then the acid neutralizes, gobbles it away. So I'm going to add little by little. And when it starts sticking around a little bit longer, I know that I might be getting closer to neutralizing my acid, and that's when I'll have to be really, really careful. But the goal is to eventually get a really, really faint pale pink color. This gets exciting. It's almost as fun as watching paint dry.
Oh, I'm on the edge of my seat.
Right? Me too. I haven't done a titration in over a year, so I just can't wait to... Ooh, I'm getting closer. Remember, we had a titration competition my freshman year at ISU. And my friend Ben, who I was lucky enough to be his best man in his wedding, he won. He was really, really good at it.
Did you guys do titrations at the wedding? The reception, I should say. It would be inappropriate at the wedding itself.
Actually, it would have worked well. The wedding reception was so exciting that the DJ ended early. So
right.
That'll go to tell you how great of a party it was.
He'd had enough, huh?
It was a Central Illinois wedding. Things were a little different than the South side, I guess. All right. Right now I'm down to about 8 milliliters on my burette. So I went from what did I start at, Mr. Brown?
4.8
to 8. So we're getting there. Oh, I'm getting closer. And the key to titration is definitely patience, something that I've
this
struggled
isn't a
with in
hurry.
my life. Hopefully, though, that pink is picking up. Notice every time I put the base in, I'm swirling it to help the base interact with the acid and neutralize. I'm glad I wore my Sandberg bracelets today to be extra festive for the video.
You're always festive. Wherever Mr. J is, that's where the party is.
Ooh, you can see now when I add the base, it's getting quite a bit pinker. So I think I'm getting closer. Ooh, yeah. Well, don't get mad at me, Mr. Brown, if I get too dark magenta. Oh, I'm getting close!
Yeah.
Oh!
Looks awesome.
Honestly, probably too much for ISU standards. I'd be in trouble.
No, I think that looks pretty good.
All right.
That's pretty good.
So right there, as you can see against the white, you've got the nice pale pink color. So hopefully, let's get a reading really quick. It looks like right on the money at 9.5 milliliters. So we started
All
at
right.
4.8 milliliters and went to 9.5. Did I do okay, Mr. Brown?
I thought it was awesome. Thank you very much. I
No
appreciate
problem.
it.
Enjoy your titration lab.
All right, so the next team member that we have here is Ms. Brill. And what she's going to do is she's going to do the same lab. She's doing trial 3. And so here she started at 20.00 milliliters, and she's going to try to run it down to 30. But again, it doesn't have to be exact because our calculation is going to take care of it. The calculation is easier if we get exactly on 30, but it doesn't have to be right on 30. All right, so go ahead, Ms. Brill.
Okay.
All right, that looks like it. So right on 30. So I'm going to write that down. Okay, she's going to add 1 or 2, 3 drops of phenolphthalein.
All right. 1, 2. I'll do 3 too.
And then she's going to come over here to this side. And just like we did before, she's going to add drop by drop. And now that since both of us has done this before, we got a kind of a good idea about where it's gonna turn pink here.
Ooh.
Okay, so yeah, it takes a little practice here. There you go. I'm gonna watch over here to see about when you get close.
Okay.
If you guys notice, it turns like each drop turns pink, and then it disappears as she's swirling it. Okay, so we probably want to slow down a little bit. We should be getting close. In line. It's
Ooh.
going fast.
Oh
Whoop.
gosh.
It's all right. Swirl it and see what happens. You're good.
All right.
It's all good. So now, if you can just add really slow, 1 drop at a time. There you go.
I should probably move my hands.
Now you got it.
Oh gosh.
Yeah. it
This
goes
is a
fast.
tricky.
Yeah, it goes fast. It's a.
You have to have a delicate hand here. Come on, Dad.
Every time the drop, it goes, okay, let's give it a good swirl. Oh, I think the next drop might do it.
Okay. Come on, Dad.
And there we are.
All
All right. So now let's read what we got here. And it says 14.48. 14.48.
Okay.
All right.
It's not too pink?
Nope, that's fine.
All right.
Thanks, Ms. Brill. I appreciate
You're
it.
welcome.
You guys, our final team member here is Mr. Bakuris. And what he's going to do is he's going to add the acid. He's going to add 10 milliliters of acid here. And again, we don't have to be exact on this. We like to get 10 milliliters in there, but it doesn't have to be exact because the calculation that we're going to do is going to kind of take care of that. And there it is, nailed it, right on 40. All right. So now what he's going to do, he's going to add a couple drops of phenolphthalein. And I'm going to give him some space so we can come around on this side and titrate.
We have a ballpark. How many we think?
It takes about 4.5 or so. A little more than 4.5. All right. So again, just like you see before, it turns slightly pink and then it disappears as we get the neutralization going. Mr. Mercuris kind of uses the same technique that I use, nice and slow and steady here when you're not sure.
It's like magic.
Yeah, it is.
It's starting to hang around a little longer. Turn that up a little bit.
All right, we're getting closer here. Every drop it hangs around, the color hangs around just a little bit more. Very close. Every drop seems to take a little bit longer, so we're getting really close. All right, I think we're there. Look at that, guys. All right, so there's our pink color. And Mr. McCurry, you want to read what it says there?
It looks like about 19.6.
Okay.
What do you think? I think 19.6.
Yeah, that's pretty close. Okay, that sounds good. All right. Well, thank you, Mr. McCurry. I appreciate your help. All right, you guys should have enough information now to finish the lab. So good luck.